Hey everyone, this is Saptarshi Goswami and we are at the 8th class of machine learning. Today we are going to discuss a classification technique which comes under supervised learning, and we will see naive-based classifier which is based on probability. So these are the things that we are going to discuss. We'll give a quick recap of probability. We'll go into the working of naive-based classifier. We'll discuss about a particular issue and how to solve that using smoothing, and we'll also discuss about advantage of disadvantage of this particular classifier. Okay, so let's start with probability now, and let's see an example. So basically the question is this, that if you roll a die, then what is the chance of getting a 6? Okay, and how do you answer this? So you think, okay, if I roll a die, what can come? uh, any number or any phase between 1 to 6 can come. Okay, so and all have equal chance to come. Okay, so the probability of getting a 6 is 1 by 6, isn't it? And if I tell you that what is the probability of getting a 1 or a 2, then you will say that okay, then the probability is 2 by 6. Okay, so this has a definition, and the definition goes like this: probability of an event happening is given as a ratio, which is number of way it can happen by total number of outcomes. Okay, so number of ways it can happen will always be less than equal to total number of outcomes. So which is the reason probability of an event is always between 0 to 1. Now let us look at some further terminologies which are associated with probability. The first terminology is called as an experiment, which is a repeatable procedure with a set of possible results. Example is throwing die. So this is often called also as a random experiment because you cannot ascertain what result you are going to get. And outcomes are any result that you are getting out of this experiment. Okay. Then comes a sample space. So sample space is all the possible outcomes of an experiment. Look at the notation here. So for rolling of a die, it is 1 to 6, and it is represented in a set notation, right? So any sample space is nothing but a set which consists of all possible experiments. Next come is sample point. Sample point is nothing but any one of the points of the sample space. Okay, so any point will be called as a sample point. And finally, event, because that's what we are reading, probability of an event. So probability of event is one or more outcomes of an experiment. Okay, so as example, an event can be rolling and getting an even number, so which will consist of 3 sample points, 2, 4 and 6. So an event can be a simple event, in which case it will consist of only one sample point, or it can be a composite event where it can consist of multiple sample points like rolling of an even number. So before we move and get introduced to conditional probability, let us look at few basic definitions. So which are union and intersection of events. So as we said that a event space, which is a subset of sample space, can be represented using a Venn diagram because it is a set. Okay, and the space where it is both within A and B, this is called as A intersection B, and also read as A and B. And the entire space of event A and event B is called as A union B, or it can be read as A or B. Okay, now let us go and look at conditional probability. So conditional probability will be typically starting with a question like, what is the probability of getting an odd number in rolling of a die given it is less than 4? So this given it is less than 4 is also alternatively read as on the condition it is less than 4. So from this way of telling, the conditional probability name comes. Okay, so now let's look at uh, the events. Okay, so any conditional probability will consist of two events. Okay, so this we call as event A, getting an odd number, and it is less than 4, this we call as event B. Okay, and with Venn diagram, when we draw, you can see that probability A or event A has got 1, 3 and 5, the odd numbers, and probability B has got all sample points where less than 4, that is 1, 2 and 3. Okay, and the conditional probability is given as probability of A intersection B divided by probability of B. Okay, so it is already said that B has happened. So in the denominator, we have only 3 sample points, and in the numerator, we have this intersection where there is these 2 sample points. So in this case, the probability will turn out to be 2 by 3. Now, it turns out again that probability of A by B or probability of A given B can be used to find out probability of B given A. How? With just simple, mathematical calculations. So from this, we can say probability of A intersection B is product of probability of B and probability of A given B, right? Next, we can say is probability of B given A is similarly probability of A intersection B and probability of A, okay? Ratio of that. Now, we already know probability of A intersection B. So we just replace this and we get probability of B given A is probability of B multiplied by probability of A given B, and then we divide by probability of A. Okay, so this is the idea that we are going to use. Now let's see how this relates to our classification problem. Let's say you are given an unknown fruit and you want to classify whether it is an apple or an orange. Okay, so as you know, this is a classification problem, so it is a supervised problem. We will already have some label data available. The label data will be of this form. Maybe we are just measuring 2 attributes of the fruits, okay, so which are shape and color, and we are labeling it. So in the fruit column it will be either it is apple or orange. So this will be pre-filled. We will have data about some of the fruits. Okay, so now how we start and do the classification. The very first step is we check probability of apple and orange in the entire database. Which occurs more, we predict the unknown fruit to be that. Okay, so we calculate both probability of apple and orange, and we see that, let's say probability of apple is more, we say this fruit is apple. Okay, so if you follow this approach, this is called as prior probability. Okay, so of course you can understand that this is not a very good approach. So you already know some of the attributes of the unknown fruit. You know its shape and color. So what you next do is you now check the shape and color of the unknown fruit. Let's say it is red and round. So from previous data, we find probability of color equal to red given it is apple, probability of shape equal to round given it is apple, and of course the corresponding probabilities for orange. So these probabilities now are called as likelihood. Okay, so now what we do is we adjust our priors using these likelihoods because we know now what are the shape and color of the unknown fruit. So when we do that, when we multiply respective prior and likelihood, we get a term which is posterior probability. Okay, not exactly posterior probability, but let us not go into technicality of that. You can understand that prior and likelihood gives you posterior. Okay, and in step 5, you see that whichever fruit has more posterior probability, you assign it in that class. So that is how this conditional probability is fit into the scheme of supervised learning or classification. Okay, so let us see an example. Let's say that there is a patient and you are measuring some of the symptoms. There are 4 symptoms, whether he has chill or cold or not, whether he has runny nose or not, whether he has headache or not, and whether he has fever or not. And the final category is whether he has got flu or not. Okay, so these are the symptoms or the independent variables, and this flu is the target or the response variable or the outcome variable. Now, as you know that you will be given a new patient who has these conditions, okay, and you will have to predict whether he will have a flu or not. Okay, so you may notice that this has same data as the first observation, but that is not how you use need based classifier, right? So you don't go for an exact match. So the first step is you calculate the priors. Okay, so what is the priors? Prior is you find out what is the probability of not happening flu. So you will see that there are 3 patients who doesn't have flu. So you calculate this as 3 by 8 because there are 8 patients, and probability of ES is going to be 5 by 8. Next, what you do is you prepare something called as likelihood table. How many likelihood tables will be required? How many attributes are there? It will depend on that. So there are 4 attributes. So you have created 4 likelihood tables. Okay. And what you do is you calculate. So you create that many number of rows as many levels are there. Levels meaning that if you see chili is a binary attribute, runny nose is a binary attribute, fever is a binary attribute, whereas headache has 3 levels. So you'll notice that chili will have 2 rows, runny nose has 2 rows, fever has 2 rows, whereas headache has 3 rows. And then corresponding to it, you just count the number. So let's take one example. So you find out that when you don't have chill, okay, then how many cases you have flu and how many cases you don't have flu. Okay, so you find that out. Similarly, for yes, you do that. Okay, so all these tables are calculated like this. Okay, and you will see that of course for all of them total count is 8 as there are 8 patients. Okay, I hope this calculation is clear. All right. Now let us carry forward this calculation and see how this will be used. Okay. So now what is done is we will try to find out probability of flu or not flu given these attributes. So this is the conditional probability that is coming into play. Okay, so let's look at the calculation now. Okay, so the prior probabilities of flu is 5 by 8 and no flu is 3 by 8. Now what we are going to do is we are going to adjust these prior probabilities by using these likelihoods. Okay, so from these tables, that probability of flu given it is chill, you can find out the probability from there. Okay, similarly you can find the probability of runny nose, probability of headache. So let's look at this particular example how we are getting this 3 by 5. So you will see that here probability of flu equal to yes is in 5 cases, and out of them probability of chills equal to yes was in 3 cases. So that's how you got this 3 by 5 figure. To understand it better, let's pick up another one. Let's pick up this one, the probability of no flu and also fever equal to no. Okay, fever equal to yes. So what is the probability of fever equal to yes? Okay, so let's go to this no flu now in fever. Okay, so this is the column for fever and this is the no flu. Okay, so you will see that it is 1 by 3, total 3 cases, okay, where it was no flu, and out of them only once it was fever, so it is 1 by 3. So that's how it is calculated. Next what you do is you multiply all of them. So you multiply 5 by 8 into 3 by 5 into 1 by 5 into 2 by 5 into 4 by 5, which results into 0.02400. And for the no flu case you get 0.009. So how your Bayesian classifier works it takes that whichever is more. So in this case you see that it is the probability of flu is more, so you say the patient has got flu. Okay, so before we look at its advantage and disadvantages and go to smoothing, so here are how this is formally represented. So we have already seen this, right? Probability of, and now we are not representing in terms of A and B, but we are representing in terms of C, which is the class, and X, which is the attribute. So probability of C given X is probability of X given C multiplied by probability of C into or divided by probability of x. Now this probability of c is called as prior and probability of x given c is called as likelihood. And this probability of x is nothing but the probability of having that condition, okay, so which is called as predictor prior probability. Now you can understand that for all the classes, when you are doing a calculation, this is going to be common, probability of x. So that's why you do not actually calculate probability of x. And another thing is there is something you assumed, okay, so what you assumed is you did not calculate a probability of x1 x2 given c. What you instead calculated is probability of x1 given c into probability of x2 given c, okay, because calculating all these combinations, probability of x1 x2 x3 or x1 x2 x3 x4 is difficult. So instead of calculating probability of x1 x2 given c, you calculate probability of x1 into c multiplied by probability of x2 into c. So this assumption is called as the independence assumption, or you are assuming that these conditions are independent of each other. Probability of fever has nothing to do with headache. So you can understand that probability is not very realistic, but that makes the calculation very faster. And that also makes it earn its name of naive based classifier. So as the attributes are considered as independent of each other, that's why it is called as naive. And finally what you do is you calculate this probability for each one of the classes, and wherever you get the maximum, whichever class gives you the maximum value, you assign or you output that to be the final result. Okay, so now let us look at smoothing. So this is something interesting. So let's say you get a new condition in headache which is severe. Okay, so if you remember that we didn't have something called as severe in headache. Okay, so you had mild, no and strong. Okay, so when you are calculating the probability, then you will calculate like probability of 2 by 5, 1 by 5 and 2 by 5. Okay, so this we are doing for the yes class. Okay, so when you have got flu equal to yes, all right. So now if you get something like severe which was not present, which you also may call as unknown, which will have a probability of 0 by 5. Now this is a very dangerous preposition because you saw so far we were using a multiplicative form. So anything we multiply by 0, the entire probability will go as 0. So that is something you want to avoid. So for that what you do is you assume that this unknown, anything unknown, it doesn't have to be severe, anything which is not there in your training set has a count of 1. Okay, and you adjust the entire probability like that. Okay, so you make milds count as 3, you make no's count as 2, you make strong's count as 3 and unknowns count as 1. Everyone is used added as 1. So that from there the name add 1 smoothing is coming. And what about probability? In the denominator you don't add by 1. You add by number of labels that are there. Okay, so here you already have 3 existing level and 1 level for unknown. 4 levels, so you'll add plus 4 to this 5. So basically this probability will now turn to be 3 by 9, 2 by 9, 3 by 9 and 1 by 9. And you will notice that here also the probability will add up to 1. Now let me tell you a couple of quick terms. So this advanced smoothing is also called as Laplacian smoothing, and it is not necessary that you will have to smooth by 1. You can smoothen by higher quantities as well. Now let us look at the advantage and disadvantage of naive Bayes classifier. So the strengths are it is simple, fast and very effective. Okay, so this is often the most baseline classifier we start with. It can deal well with noisy and missing data. Okay, and it requires very less number of examples. Okay, and also can work with large number of examples. And it is easy to obtain the estimated probability for a prediction. Okay. However, the weakness is that it relies on a faulty assumption of equally important and independent features. Okay, and naturally it is not ideal for datasets with large number of numeric features. So if you have noticed, so we have dealt with only discrete probability. So naive Bayes only works with attributes which are discrete in nature, and estimated probabilities are less reliable than the predicted class. So you could see that the estimated probabilities were very small. Okay, so that is not something you can use for any practical purpose. You are more focused on the prediction of the class. Okay, so thanks for watching this video. I hope you have understood some part of naive Bayes classifier. So in lecture 9 we will follow up with hands-on of naive Bayes classifier. Thank you very much for watching this video.